The cost of renewables has been coming down every year for the last 20 years. There's been a dramatic decrease in costs recently, and with the extension of the ITC and PTC production tax credits that will enable the renewable industry to be competitive for several years to come as prices continue to decrease. And so that's really driving the market as far as new generation being added onto the system. Historically, renewable projects have been of the size around 25 to 75 megawatts. But what we've seen recently are these mega projects where there's a 300 megawatt solar farm or a 500 megawatt wind farm. Obviously, this gives economies of scale to the developer and the utility that's operating the generation facility. And so it's a different way of approaching it, more concentrated. But at the same time, we're also seeing very small projects where it's more of a microgrid, where it's a 1 megawatt or 2 megawatt block. These distributed energy resources can be sited closer to the load at distribution level voltages rather than needing the very expensive and hard to accommodate large transmission lines. The large increase in demand of additional renewables coming onto the system has driven an increase in the production and sophistication of storage resources on the system. What we've seen a trend in the recent years and the last 12 months is most renewable resources have sited storage with them. So rather than having the generation profile be dictated by the arc of the sun or the windiness of the environment, it's mitigated and smoothed out by the on-site storage. System reliability is impacted by the addition of renewables because it creates a new load shape, a new net load, because it's offsetting other resources. At the same time, having distributed energy resources allows you to site closer to the load. Having on-site storage allows the ability to provide some voltage supported energy backup closer to the load pocket. To further help with reliability, longer term storage has been being developed, and we have historical methods like pump storage, the Tomsock facility here in Missouri, but there are also future ways that we can approach longer term storage, seasonal storage, storing hydrogen and burning that, or using gravity storage where you're moving concrete blocks around to store energy for later use.
So we have a strong relationship with utilities, both local and remote. And when folks want to add a renewable project, they need to incorporate that into the larger electrical grid. And there can be a challenge as far as how to do that easily and efficiently and in ways that are to the correct standards. And so we are a really good go-between between the utility and the client, depending on what they want to do in a renewables project and how they want to get that incorporated. From start to finish, we can help your project get incorporated into the electrical grid and work with the utility and getting your renewables project started and finished. So we have civil engineering that can help with the surveying, grading plans. We can help with the interconnection studies on the electrical engineering side of things. We can support structural projects. So if you have a renewables project that you want to mount on a parking garage, for example, or a carport type infrastructure, we can support that on the structural engineering side as well. And then when that project goes to be installed, we have a strong relationship, again, with the utilities that we can work on that startup and commissioning and getting those systems started up and running. The market, people really just want renewable, cleaner energy. Where we see a lot of that happening is obviously solar. Solar is becoming cheaper and cheaper. So I think solar is going to be a really big component in energy going forward. Another component of that is electrical vehicles. You can see it now with companies like Ford or Tesla, VW. They're all now either have established vehicle fleets of electric vehicles or they're now producing more commercial grade electric vehicles. So with distributed energy resources, or DERs, they could be solar, they could be wind, they could have a battery system component, they can be a whole variety of energy generation source. And where we perform really well is how to integrate that energy, that resource into the grid. A lot of times that system will need to be stepped up to a certain voltage, to a medium voltage component that the utility uses to transmit energy throughout their system. And where CDG really plays a good role is not necessarily on the specific energy resource, but how to get that resource incorporated into the electrical grid and useful by a utility.